Hello everyone, and thank you for joining us. Welcome to today's L3 Harris Geospatial live webinar, What's New in SARscape 5.6. My name is James Slater. I'll be the moderator on today's webinar. I'm excited to be joined by Nikolai Holzer, Sales Engineer in EMEA, and Alberto Moroni, European Business Development Director. Nikolai and Alberto, if you can just say hi quickly, that'd be great.
Hello, this is Nikolai.
Hello, Alberto speaking. Hello.
Thanks both. So just a couple of housekeeping items before we get started. There'll be a short Q&A, question and answer at the end of today's session to answer your questions. I've muted the phone lines for all attendees, so if you have a question at any point, please feel free to enter this in the question chat box, and we'll get to these at the end of the presentation. I also need to let you know that we're recording today's session, and I'll make the recording and slides available later. We have just 30 minutes scheduled today to get through everything we need to, so we'll move quite quickly to cover everything we want to show you. Now, before I hand over to today's presenters, I'll say a few words on why synthetic aperture radar is not only relevant today, but why it's really specifically exciting and relevant at this time. So we think that SAR is really about to revolutionize Earth observation. For years now, optical satellite imaging has shaped the way we understand our world. A multitude of applications, including defense and intelligence, national security, agriculture, emergency response, economic forecasting, oil, gas, and utilities have benefited from really enhanced optical analytic insights, but often to varying degrees. And whilst there's no question of the value of optical imagery, some limiting factors, including capacity, cost, and cloud cover, are key challenges to achieving the promise of ubiquitous, coherent operational change detection. SAR's properties overcome many of these challenges, making it ideal for high revisit, high resolution activity monitoring, displacement modeling, feature extraction, and many other applications. While recently planned SAR sensors from operators such as Capella, ISI, and ESA's Sentinel-1 mission help solve inherent limitations of optical systems, driving new possibilities. To meet the explosion in demand for SAR analytics, ENVI SARscape 5.6 is uniquely positioned to help users realize SAR's potential through industry-leading sensor support, comprehensive automated analytics, and connectivity to class-leading optical image processing systems such as ENVI. So in today's session, we'll share not only the enhancements at 5.6, but also give insight to users looking to run large-scale, accelerated, and parallel SAR processing. So that's the quick introduction, and I'll turn it over to Nikolai.
Thank you, James. The topic of today's webinar are the new features and improvements in the new release of ENVI SARscape 5.6. But before we get into the details, I want to say a few words on our product ENVI SARscape for those that might not be so familiar with it yet. ENVI SARscape is the industry-leading advanced radar processing technology to process and analyze synthetic aperture radar, so SAR data. It is a module to ENVI to exploit all the technologies today available for end-to-end processing and information generation from SAR data, including amplitude, phase, coherence, polarimetry, interferometric SAR, differential interferometric SAR, and interferometric stacking through persistent scatterers and S-bus, and more. ENVI SARscape can manage all SAR spaceborne sensors, commercial and military, as well as various airborne sensors. And it contains more than 150 different SAR workflows or processes which can be utilized to process, analyze, and enrich SAR data. Highest priority is put on accurate and scientifically proven algorithms, operational usage and robustness, while full spectrum of sensor support, as well as flexibility and ease of use. SARscape is developed and maintained by SARmap, a Swiss company founded in 1998, and exclusively distributed by L3 Harris as an integrated module to ENVI. There are many new features and improvements in SARscape 5.6, but let us start with the new supported data formats first. SARscape 5.6 adds preliminary support for standard products acquired by Cosmos Skymet 2nd generation, which is an X-band SAR constellation. And from the first constellation of 4 sensors, supported products include the SES single complex, DGM, multi-look ground range, and the GEC ellipsoidal geocoded. The import process has been validated using a small dataset only, and for this reason, we can only provide preliminary support for this new supported sensor data. Preliminary support was also added for slant plane products acquired by any of the new very high-resolution X-band Capella space constellation satellites, having a resolution of 50 centimeters with a foreseen revisit time of 4 hours. The supported products are geocoded and terrain corrected using a digital elevation model and the SLC singular complex. Preliminary support was also added for Canada's new generation C-band RadarSat constellation mission. Please note that also for this new type of sensor support, since until release date only a small dataset could be used for validation, we can only provide preliminary sensor support at the current point in time. The supported products are SLC singular complex and GRD ground range georeferenced, which is equivalent to the SGX, SCN, and SCW products for RadarSat-1 and RadarSat-2. There are a few ways to define the geometric coordinates of the SAR images resulting from the process of focusing of raw data collected by SAR sensor data. One of these is what is used by the polar format algorithm, PFA, a technique alternative to the more standard algorithms that uses land range azimuth geometry to annotate the focus data. SARscape 5.6 adds preliminary support for the polar format algorithm, PFA, which is used in the sensor-independent complex data format, SICD. SICD is an imaging data format which is used among others by the US government, including the National Geospatial Intelligence Agency, NGA. The new ESA scientific Sentinel-2 download tool allows users to perform a query and download Sentinel-2 data from the ESA Scientific Hub. The aim of this tool is to visually compare SAR and optical data. Note that an account with login credentials is required. When started from the SARscape tools in ENVI, the downloader is executed as a standalone detached window, so the downloading process does not depend on ENVI, meaning it is even possible to close ENVI while the downloader will continue to run. The new Sentinel multi-download tool allows users to perform a query and download Sentinel data from both the ESA Scientific Hub and the Alaska SAR facility. It reduces the downloading time by taking advantage of 2 providers from that a simultaneous download is possible. The ESA Scientific Hub for the most recent online data and the Alaska SAR facility for older data by taking advantage of the online data archive in the ASF. Also for this tool, when started from the SARscape tools in ENVI, the download is executed as a standalone detached window, so it's possible to close ENVI while the downloader will continue to run. The new basic layover and shadow mask tool provides visibility analysis for SAR applications to consider possible geometric distortions and target visibility issues in advance. Layover and shadow effects are influenced by the geometry in range direction and the topography. And for this reason, the projection of individual points onto the slant range plane varies with respect to the incidence angle and the slope. The layover and shadow mask tool generates a layover and shadow mask and optionally the local incidence angle map, which can be provided in both original slant range geometry and geocoded geometry. The output can be considered as a validity measurement mask which allows to check whether a specific type of SAR analysis can be carried out in a certain area, or if it is more appropriate to use different data with a different illumination angle in order to carry out that analysis. To precisely estimate the coherence and filtering interferomograms, a non-local filter specifically designed for INSAR and based on interferometric phase and amplitude similarity has been added to SARscape 5.6. The newly implemented non-local filtering method is a flattened interferogram filter which enables to generate output products with reduced phase noise. See here in this ultra-high resolution PFA data with boxcar filtering versus the new adaptive non-local INSAR filtering. It is available in various tools of SARscape that require interferogram filtering, such as the adaptive filter and coherence generation in interferometry phase processing tools, coherence or multitemporal coherence in the basic feature extraction tools, or in various workflows that are related to interferometry and coherence. Coherence generation, non-local phase filtering provides good performance in medium and ultra-high resolution data coherences. It preserves details on point targets very well and strongly smooths the homogeneous areas. Here's another example on medium resolution data. So again, boxcar filtering versus the adaptive non-local INSAR filter. Note that non-local filtering is computationally very demanding due to many comparisons between different image areas. And for this reason, our implementation is entirely written in OpenCL to take advantage of the massive level of parallelization offered by modern graphic processing units. Hence, we recommend to use this filter in combination with a powerful GPU selected as the current OpenCL platform or device. But it's also possible to select and rely to a CPU-only OpenCL platform, but in such case, performance will roughly be 1 order of magnitude lower than using a modern GPU. A complete set of tools to process continuous tomography is now available in SARscape 5.6 for 3D SAR, radiometric, and geometric reconstruction. SAR tomography is a method by using multiple SAR images acquired from slightly different looking angles to reconstruct the reflectivity of the scattering objects along the elevation direction, as well as the 3D positions of the scatterers. Interferometric stacking continuous tomography allows resolution enhancements along the SAR elevation direction by exploiting a series of interferometric images. The continuous tomographic method relies on coherence of the phase history of the interferometric series. The results depend on the band sensors, best results obtained from L-band and P-band. The method is suited for retrieval of backscattering coefficients in case of volume scattering, for instance, forest canopy, which implies that a series of SAR acquisitions at longer wavelengths, so L or P-band, that is capable to penetrate within the scattering medium are used in order to obtain meaningful results, such as, for instance, biomass estimation. It's not suited for urban scenarios or shorter wavelengths, such as X-band, where the predominant backscattering happens at the surface of objects. This ready-to-use tool particularly supports future satellite missions like biomass of ESA for instance, forestry analysis. The tomographic technique provides elevation slices, so vertical slices within the tomogram. A tomographic slice is simply a cut at a given height inside the 3D tomographic SAR image cube. The precise height of scene features can be measured when looking at the actual intensity values of a given pixel at different heights. In the figure on this slide, we can see an example of the tomographic slice feature with 9 slices. Each small image corresponds to a layer of the cube at a different height. The height is here the residual with respect to the SRTM-DM that was used for tomographic processing. The changes in brightness that we see in this series corresponds to the fact that some features of the scene actually have a different height from that provided by the SRTM-DM. To give you an example, when looking at the bare soil region, we can see that this area becomes darker if we move toward greater residual heights, so negative values and positive values. So an area of bare soil is here in the left part and the road within this bare soil region. When looking at this region, we can see this area becomes darker, particularly at these more positive heights, and darker at these more negative directions. And this means that the true residual height of the terrain is quite close to the SRTM height. So with the tomographic method, the precise height of scene features can be measured through the intensity values of a given pixel at different heights, where the correct height will show with the brightest peaks, which is here in the middle with the lowest residuals. The new tool, dual polarimetric entropy alpha anisotropy decomposition in SARscape 5.6 Polarimetry and Pol-INSA module, is a dual pole version of the quad pole entropy alpha decomposition that is already existing with SARscape. This tool allows the alpha entropy decomposition on HHHV or VVVH dual polarimetric single loop complex datasets. So on co-polarization, cross-polarization combinations of dual polarization SLC data. It is hence dedicated to sensors that only provide dual polarization data, such as it is the case for Sentinel-1. In general, the incoherent decomposition approach is suitable for discriminating the scattering of complex targets, such as natural features. The example on this slide shows an eigendecomposition of the coherency matrix of a dual polarimetric, so HHHV or VVVH, single loop complex dataset. To facilitate the analysis of the physical information, which is provided by the eigendecomposition of the coherency matrix, two secondary parameters are defined as a function of the eigenvalues and eigenvectors, which is entropy and alpha. And the technique allows good enough performance with respect to the quad polarization data and tools. So here we have the dual polarization results versus the quad polarization results from the tools that are already existing in prior versions of SARscape. SARscape 5.6 also includes new features for maritime applications. The new tide height download tool allows downloading tide height measurements or estimates for any location in the world provided by the tide monitoring station database World Tides. It is particularly supporting the identification of coastlines, which, for instance, is required as input for the ship detection tool in SARscape. Tide height download is available for any location in the world, and the information is provided in shapefile format as point features. The ship statistic tool in the new ship feature submenu in SARscape 5.6 computes and displays the monthly average number of ships detected from SAR in a certain area, if two or more acquisitions are available. The monthly average is created in CSV format, from that a quick view plot can be generated in a second tool. The new EnviSeries to NetCDF conversion tool allows the conversion of ENVI meta files, EnviSeries files, and list files in the NetCDF format, the Network Common Data format. The NetCDF format is able to store multidimensional data, and with this tool, it's possible to convert SARscape output results, such as from time series, SAR intensity, or time series deformation, as bus processing. The NetCDF conversion enables the import of such multitemporal data in other tools, such as ArcGIS, to allow further analysis of temporal displacements or amplitude evolutions. With ENVI 5.6, we introduced ENVI Server, a server-based technology that allows to run processing remotely or in the background of an ENVI desktop session. And starting with version 5.6, SARscape now supports the new ENVI Server technology as well. And to that regard, already ships with one free background processing capability. The main benefit for customers leveraging ENVI Server with SARscape is simply to save time by letting SARscape take the full advantage of powerful machines and modern hardware. Either bulk processing of SAR data in the background while visually inspecting the outcomes, and or to realize distributed parallel processing chains on powerful network machines with common data access. When SARscape is used in combination with ENVI Server, automated, reusable workflows can be made turnkey for operational implementation and deployed for large-scale SAR processing from desktop to enterprise environments. Most of the SARscape tools in ENVI Desktop can be also run through SARscape tasks, which can be executed independently or joined together in the ENVI modeler. And this simple and intuitive visual programming tool allows to customize workflows that can then be easily used to realize repeatable automation, batch processing, rapid algorithm development without any knowledge of ENVI programming. And now regarding SARscape tasks for workflow development in ENVI Modeler and the new SARscape ENVI Server support for background and distributed processing, my colleague Alberto Meroni will now give you a short live demo. Alberto, please, over to you.
Good morning, ladies and gentlemen. Today I have the pleasure to show how easily a meaningful SARscape processing chain can be realized using ENVI Modeler, how we can run it via ENVI Server, and while it's running continue to work and interact with ENVI. How we can publish our model in order to enable its use in other computing infrastructure, such as a local server or a cloud environment. How we can add new ENVI server to our ENVI desktop, increasing our capability to process data. Now, one step at a time, let us first discover how we can build a model. The model that we build today is a multi-temporal coherence change detection. For SAR scene are used. From each pair, the coherence is estimated, and the result of each pair is used to color a color channel of an RGB composite, resulting in an image that highlights changes and the time range associated with those changes. So let me start ENVI Modeler. First of all, we add to our model some basic nodes that enable us to input and output data. Then we add the real processing task, so multi-temporal coherence generation, geocoding, color composite, then we have to as well import and use inside our workflow a DM. The DM is in ENVI format, so we use a task to ingest an ENVI file format inside a SARscape processing chain, and then last step, extract element from array, and we will see later why we are using it. Now we just need to connect all the components all the tasks of our processing chain. So first of all, let's connect the parameter with the input and rename them. Here we have input S1 product. Here we have input. We need to input the digital elevation model. And since this task is processing an array of images, we need just to select one. So that's why we are using a start element from array. So here is coming out an array, and then we select just the first element because we just need one digital elevation model. Then we connect the digital elevation model with the input of the digital elevation model of a multi-temporal coherence generation, and the output of the multi-coherence to the geocoding. VDM, we use VDM as well here, and then we the output of the geocoding to the color composite. We select the type of color composite that we want to extract, and then finally we connect the output to the output parameters. So just a few things to tune. Let's see here the parameters, and then I want to use a kernel a little bit wider, larger, to estimate the coherence, to highlight the changes that are the most important changes inside our area of interest. Then let's see the parameter here. Fine again. Okay. So now I think we are ready. So let's test, validate the model. The model is fine. Now we can run it. Since we want to run it inside our ENVI server, we use this error and then run model in the background. Then we select the input files and the input Sentinel-1 product 4, generating 3 coherence layers that then will be merged for generate the color composite finally. And then the digital elevation model. Okay, now the interface of the ENVI server job console is started. Now here we can see that the job of ENVI server started the job and now is processing our model. We will come back later to it. Now let's review other important functionality that ENVI is providing to us. The first one, we can generate from this model a meta task. By just clicking a button, we can generate the meta task, and this functionality allows us to publish the task inside our desktop or inside our desktop, but then move the file inside other infrastructure and enable the use and the execution of our meta task in other computing environment, such as a server here or a cloud environment. We can even generate an ideal program from our model, and that allows us to review all the parameters, set our parameters, change adjust the workflow on our need, and so on and so forth. Extremely easy. And you will also appreciate how all the parameters are exposed. Simple, easy, to modify. Then we are using a local ENVI server on our desktop. But ENVI desktop enables us also to manage the server by adding other server. So adding computing resources to our desktop. So I can do that, add, and I can add a local server that is here in my office. And I call it Office Server. And then I select the data space where I will share the data. Okay, and it's done. I don't need to generate a model to run a task inside the ENVI server. I can even run directly a simple task. And I just use this function, run ENVI server task, and if I select this computer, I can access to a task, for example, the geocoding, radiometric correction, run it, and as you can see, I can set the parameters. So, for example, I select one image of a processing chain that we are executing, and then a digital elevation model, and then I can submit as well to ENVI server the execution of this task. And now you can see that we have two tasks that are running, and then I can even select task on my Office server, and for example I can select the task that the model that we are currently running here, select the parameter and run again on another server. So building a federation of ENVI server, adding capabilities to process data to my enterprise, to my desktop environment. Okay. Now let's load some data from Sentinel-2 that is showing what we are trying to highlight with our workflow. So let's load a Sentinel-2 data collected at the beginning of June of 2019, and then an image collected at the beginning of July 2019 again. If I have as a background the image at the beginning of June, and then I display in a portal the image collected at the beginning of July, you will note a difference here in white. That is a path that has been built around the airport. Here you see. Then you can also appreciate the difference that there is here around this infrastructure. Okay, let's now see if our task is completed. It's close to be completed. Okay, it's completed. Let's load the task and review the result. Close. As you can see, the changes are highlighted in different color because different colors means also different period of time. Red, green, and blue. And let's just use view flicker of ENVI in order to highlight the difference between that our analysis is reporting less. That's all from my side. Back to you, Nikolai. Thank you.
More of the improvements in SARscape 5.6 are listed here on this table, which include, for instance, workflow improvements to import data, perform sample selection, some spatial subsetting, and download a DM in a single step, performance improvements in a wide area of persistent scatterers, and several functional improvements in SBus, in the time series analyzer plot to highlight interpolated displacement values in a time series graph, and a new set of preferences for different spatial resolutions. New, by the way, in SARscape 5.6 is also the DM extraction to have access to the GMTED 2010 DM that replaces the GTOPO 30 DM, and a download option for TDM90, so the world DM of TanDEM-X at 90-meter resolution from the German Aerospace Center, which is the most recent DM available for free. So as I have shown you so far for the new ENVI SARscape 5.6 release, it is really packed with a variety of new key features, additional data format support, and general improvements now coming to an end. Let me thank you for your attendance and giving the word back to our moderator, to James. Thank you.
Hey, thanks, Nikolai. Thanks, Alberto. We're at the half now, but maybe we'll have time for a couple of questions. We'll just squeeze these in. So the first one to Nikolai, it's less of a question and really a clarification. We've had some interest on your slide, continuous tomography. Can you say a bit more about that? I'm not sure if if it was clear to everyone in our audience what you were showing there, so that might be worth a revisit.
Okay. Yeah, I assume it is this figure here that I admit I haven't explained. So this is a tomographic slice in the height slant range direction, so the height slant range direction. And this figure shows the true reflectivity height profile through the tomogram. So there's a tomogram up here in slant range direction. So we see here the amount, or let's say the fraction of reflectivity at a certain at a certain slant range position, at a certain pixel position, at different heights through the volume scatterer. So this is a volume scatterer. It can be, for instance, a forest, and here above is the forest canopy that you see here from the LiDAR. From that LiDAR profile. So the LiDAR profile, you see here the surface reflections at the forest vegetation canopy, whereas the L or P band penetrates through that volume scatterer, and this allows comparison of the SAR reflectivity heights, for instance, in case of forestry for biomass estimation. This is one of the applications. Okay.
Thank you, Nikolai. So just a quick check through the questions and some interest generally about really operational utilization for SARscape 5.6 for persistent monitoring services. Alberto, I know that's something that your demo was seeking to show. So can you perhaps say a bit more about that? It seems that this is of interest. So specifically of interest is to identify changes and anomalies, in an operational way. Can you say something about that? Something else about that?
Alberto, you're muted. Otherwise, I can maybe also help with that question. So my understanding is, I understand the question is that.
Okay. Now,
okay.
Nikolai, now I'm back. I'm no more mute. Okay, yes, you can set up an ENVI server that is basically monitoring areas, region of interest, and then look inside the catalog, such as the ESA or other catalog, start and triggering an automatic process to generate ready-to-use data, for analysis. And the task system and ENVI server enable you to perform this task in an easy manner, meaning that you can use the ENVI modeler to build up your workflow. Then you can deploy your workflow in ENVI server, or what we call ENVI enterprise version of ENVI, and then just analyze the data as soon as the data is available, and then distribute the result to the people that need to review the data.
Okay, great. Thanks for that, Alberto. So yeah, we're at the close, I think, at this point. Apologies for the live demo section. What we'll do is we'll try to backfill that, so the recording, when it goes out, we'll try to get the demo up and available to you. Of course, for any questions, please feel free to contact Alberto, Nikolai, or myself, James. And yeah, we appreciate your attention and your attendance to these webinars. Thank you again, Nikolai and Alberto. In case we didn't get to your question, then we'll try to follow up with you individually after this webinar. And as I said, a recording of the webinar will be going out probably in the next week, and a copy of the slides will be up on our website, l3harrisgeospatial.com. So thank you everyone for attending. Thanks to our presenters, Nikolai and Alberto.
Thank you and goodbye.
Thank you.
Thanks everyone. Goodbye.